All right, so last meeting we started to discuss BJTs. Okay, BJTs or bipolar junction transistors. Okay, sige. So, hindi man ako makita yung mga response no kung mag-kuan ko. Ah, try na. Cancel ako kung kuan na. Lagi. So, solicit na ako mga answer sa inyo ha, pero mag-sim-sim na ako makita ang inyong mga responses sa chat. Pero kung makatupag mo by opening your mic, that would be better. Okay? So, BJTs are a type of transistor. Compared to the diode, it has 3 terminals. So, muna iyahang schematic diagram. This is an NPN na transistor. It has 3 terminals. The collector over here, collector, kung asang arrow, ang emitter, and kung asang kaning horizontal na line, unang base. Okay? So this is an NPN BJT. No? Wait lang. So NPN BJT. It has 3 major regions of operation with respect to its characteristic curve. 3 regions of operations. We have the active region, the saturation region, and the cutoff region. So all of this, ang ako lang ipang point out is are those points that are very important for our discussion this afternoon. Pero I guess we've already covered this one in detail last time, no? So try to review na lang based sa notes, no, natong gigamit last meeting. So if we want to use our transistor, we should use as an amplifier. We should use it in the active region, no? Amplifier. And as a switch, change state from saturation to cutoff and vice versa. So it will be used as a switch if nasa kaninga regions. Okay? So gamay lang visual. Nga nito isura sa atong characteristic curve sa atong BJT. So for different values of IB, it may look like this. So muna siya ang active region. Dihang apart. So active region. Saturation region. Current is high. Voltage is low. This region. Cutoff region. Opposite. Voltage is high. Current is low. And any other regions outside these 3 is informally, no, we call that one the breakdown region. Breakdown. Meaning, if ang operating point is somewhere outside aning 3, our BJT will be busted. So kung magdraw ta og load line, no, we call that one the load line to determine the operating point. And if we want to use the transistor as an amplifier, the intersection between the load line and the characteristic curve should fall within this green area, no, the active region. So example lang ni. So dapat na diya, no? So if na ang atong intersection sa load line and characteristic curve somewhere here sa blue, so saturated siya or not siya sa saturation region. If nasa kuan, if makapen lang pud na if steep pud kayo ang atong characteristic curve, no? So naa diha. If balipod, no? Opposite sa steep, naa dire. So nasa cutoff ang atong characteristic curve. So cut off siya. Wait lang. And if na-outside ani nga mga three regions, let's say for example, nagdolog ko characteristic curve, then naa-dire, no? So outside siya sa active region. So technically, mahulog na siya nga breakdown region. So maguba na itong transistor, ana. So for this afternoon, and siguro for more meetings, no, to come, for more meetings to come, we'll be focusing on using BJT as region. Okay. Here. So siguro pohon, we'll have some examples of circuits or configurations na makakater o the BJT. Okay, meaning na siya saturation and cutoff. So both niya in tandem ni duha gamiton simultaneous sila, saturation and cutoff, toggling one state to another and vice versa. Pero again, for more immediate meetings to come, focus ata dire, the amplifier. The first step we should do is that the transistor is an electronic device. We should first, sa totong term, when we say the turning on of the electronic device, the turning on letter B. It's applying bias. Okay. Yeah, we won't forget. Makita inyo again, no? So it's applying bias. That's how we turn on our transistor. And if we bias it properly, so that ang region of operation is nasa active region, so hindi dato siya nagamit as an amplifier. So turning on of the device, not only the same sa the same sa diode. It's not only the application of a voltage source. Okay. So, if correct, no, correct ang flow and directions sa currents. But medyo complicated lang gamay in this case because we have three sets of currents and voltages, unlike sa diode na isa lang, no? Isa lang voltage across it and isa lang current through it. Okay? So dili medyo kuan siya. Complicated gamay. Pero still, we'll go through it one by one or step by step. So, amplifier, no? In a systematic analysis or systems point of view, this will be the symbol of the amplifier and characterized by its gain. Okay? Or A, sometimes it's G, or sometimes A na siya. AV, meaning voltage gain. Meaning, whatever is the gain, let's say for example, is a unitless value. The gain is 1,000. Okay? So, ma-multiply niya 1,000 times whatever signal or value of the voltage na nasa input. And the output will be 1,000 times that value. So, let's say for example, ang atong input voltage is 1 millivolts, commonly occurring amount of voltage if we're talking about sensors. Sensors kay nasa inga na nga range sa input voltage. So meaning our output would be 1 times 1,000 millivolts. 1 millivolt times 1,000 would be 1 volt. Okay? So I think that's understandable. So if ang gain is 200, so 200 millivolts na siya. So on and so forth. Okay? Now, question, what if akong input lugar is 1 volt? Would like to guess what the output would be?
One kilovolt, sir?
1 kilovolt. Okay, muna atong guess, di ba? So, pero is this really? Are we seeing amplifiers used like observe na mo ani class practical na sense yani ang purpose of amplifier. Where do we usually see amplifiers? Kung may amplifier wala iyang kay kay man ang context na to is amplifier in a general sense, right? A general type of practically where do you usually find amplifiers sa unsa nga klase nga application? And I think that ay common application mo kung may tag amplifier. Unsa nga aspect, unsa nga area, or unsa nga application na siya. Unsa nga appliance, no, sa balay. Yan lang para medyo.
Microphone.
Okay, microphone. Or ang input is microphone, so sound system, no? When we talk about amplifiers, we usually mean sound amplifiers, no? Or sound system. May microphone, may speaker. Maybe sa karaoke na to gi-connect, no? Ipa-on sa ang amplifier. Common na siya nga term. I-on sa amplifier ka. So, it would be accurate to say nga pasabot ato is the sound system. No? So, kung amplifier lang yun dito is that part of the circuit that amplifies the signal. In this particular case, ang signal nga gikan sa microphone. But, is this realistic? Have you ever heard of this nga type of amplifier nga ang input is 1 volt then maka-output siya of 1,000? No? So, medyo kuan siya, no? Unrealistic. Okay? So, ang makatubagan niya question, why is it unrealistic? No? That question, why is this not commonly observed? No? Ang answer to that question, or ang concept behind sa answer ng question is the same sa concept behind the question nga, how can the amplifier amplify voltage or current pagkaha or power? No? So, how does the amplifier give a gain, no, of 1,000 or 5,000 or even 1 million, no? It's very possible to have an amplifier nga na gain of 1 million, no? That's times 10 to the power of 6. Is that so? Yeah, because if atong input is 1 microvolt, then 1,000 1 million yung gain, so yung output is 1 volt, diba? So, kuan lang, no, observable. But if input lugar na to is 1 volt, so ang output is 1 million volts. 1 million volt. So medyo realistic na naon. And that is correct. Wala dili nga ng amplifier, no? There's no such thing as an amplifier that works like that. Why? No? Why is it impossible for amplifiers to output 1,000 or 1 million volts? And why does the amplifier amplify voltage or current or power in the first place? No? So answer ana, no? Why does the amplifier amplify? And why can't it amplify voltage? Why can't it amplify very large amounts of voltages? It's because its maximum output, take note lang ni, the amplifier is not it's not a magical device, no, that could do that could turn our 1 volt into 1,000 volts. Even, no, even if ang gain sa tong amplifier is 100, no, even if 100, then atong input is 1 volt. You can't expect na 100 volts po di ang output, no, it doesn't work that way. So its maximum output is only dependent, uh, is depend the applied supply voltage. Okay. Term the voltage vector BCC. So the maximum output is dependent on the applied supply voltage. Yung supply voltage is only positive 3 volts. If one gain, no, so let's say, for example, I have an amplifier. Upper gitna is my ground and my VCC. No? Let's say 3 volts. So okay lang to kung 1 millivolt na eh. So output is 1 volt. Mas kamay pa man ng 1 volt kaysa 3 volts na siya. Ang 5 millivolts ang input. So expected unta nga 5 millivolts mo 2,000 nga gain. It is expected that ang output dili is 5 volts. But dili na may tabo. Maubos po siya. What if tangan lang na 1,000 volts or 2,000 baka para if 1 volt ni dire pwede na atong ginanglan nga 1,000. So dili gyapon because again if we try to plot sa characteristic curve ang kaninga example outside na siya sa active region na siya breakdown region uba po datong transistor ana. Okay, so ang key ang key concept the amplifier can amplify voltage hundreds or thousands of times larger is because of the applied supply voltage. No? Remember lang nato na siya kay basig mo makalimot daw ta nga nana siya nga limitation, no? So okay. So biasing is the turning on of the device. Now there are numerous ways on how to bias the transistor as an amplifier. Okay, again, as an amplifier, there are numerous ways. This afternoon we'll only introduce one at least, no? Before we proceed with our midterm exam, isa lang sa at least we know one. But after midterm, ato i-discuss tong most common biasing circuits. Dili tanan, dili maging tanan atong need may balaan. At least ang sum lang, no, kay ang analysis sa isa ka biasing circuit is the same naman sa all the other circuits. So I think we'll only discuss 3 or 4 siguro at most on the biasing circuit. Okay. So the simplest of all is called the fixed bias configuration or fixed bias circuit. Fixed bias. This is the simplest of all because it only requires two resistors, one external supply, sa isa transistor, no? Two capacitors, and because of its simplicity, mo gyapon ni ang circuit if we want to use the transistor as a switch. So fixed configuration. So yan iyahang itsura. This is how it is commonly drawn or written. Hindi lang sa textbooks but also sa mga schematic diagrams that we will be encountering. Schematic diagrams sa electronic circuit and systems of for higher subjects before ang resistor. Unang sa nakugdo ang transistor. So that is my transistor, collector, emitter, base. We connect a resistor sa collector, and we also connect a resistor to the base. The emitter connect directly to ground, and both ang base resistor and collector resistor is i-connect og voltage source. So we call that one VCC. So this is our RC, this is our RB. And our transistor is characterized by DC voltage gain, DC gain beta, current gain beta. Supposed to be dili i-connect ang capacitors. This is the output terminal, and this is the input terminal. Okay, fixed bias configuration. So kung i-draw nato ni as a system nga kuan, system nga block diagram, yan na lang siya, muning input, munang output. I-label natin ni fixed bias, kabalo na tayo sa components nga sa sulod. No? So, this one. Now, one characteristic of the capacitor is it blocks DC signal. Okay? It isolates DC signal. So, ang DC signal here na in play is due to the voltage source. So, in that, because of that, whatever it is ang i-connect nato sa output, let's say we connect a speaker here. No? Speaker. And sa input is mag-connect ta og microphone. Nga. Yeah. So we know input sa microphone is an AC signal from the voice of the person, and ang output is sound waves gapon, AC signal, alternating current. So ang purpose sa capacitor, these capacitors isolate the AC signal from the DC signal. So that ang kaning DC source dili maka-interfere. Dili maka-interfere sa signal source, which is the microphone and the speaker. So i-isolate niya kibali. I-isolate sa capacitors ang microphone and ang speaker. Para di sila, or at least para di sila ma-influence sa DC voltage source. And vice versa. Para dili pa maka-influence ang signal, AC signal, the input AC signal and the output sa biasing, no? Sa pag-turn on sa atong transistor. Okay? So because of that, pwede ra sa nato i-ignore ang effects ni source and ni load, ni microphone and ni speaker. So ato sa nas lang i-ignore because of the capacitors. So tangtangon sa ato si capacitor. Wala pa role nga i-play si capacitor sa uh, analysis sa DC biasing. Okay. So wala pa sila. So ang fixed bias configuration is only this one. Sa DC analysis sa fixed bias configuration, only the two resistors and the transistor itself. Okay? Yan na lang. So, sometimes it's really clear, no? Para i-draw ng circuit. Even ako before, akong dan nga kuan it sa na mga box na mga circuit nga ground. But here, na to, no? Well, in fact, itong DC source is masyag, no? Voltage source like that. So it might be convenient to withdraw this one. No, I withdraw. This is not mandatory, no? Nor is it required. But again, it might be convenient for some of you na nagasugod pag-analyze of electronic circuits. No? So we could withdraw this one. And nato, notice na both si resistor RC and resistor RB are connected to the same VCC. No? So connected sila. So pwede na ito sa separate ay para as if, no, logically isa lang magid ilahang gi-connectahan, but logically pwede na natin sa label without making any difference to the circuit. No? It may look like this. Okay. RB, RC. Pwede nga na. Okay. Both of these are VCC. Same value. Nga. So kani, pwede pagid nato ni withdraw pagid even further. Especially if we know nga if ang source is ingani ang iyang pag-describe, pwede ta magbutang og action, no, na symbol for a DC source. So malag as if bitaw nga i-bend lang nako na siya pa didto. And same gyapon si VCC, bend lang nako na pa didto. So may tabo sa iya is kani si transistor VCC kani si RB same gyapon this is VCC and this is RC. Okay. So subtanda, is there in any question? Sige, sa ako pag-derive ang akong withdrawn circuit. Yan ka na, parela. No. Again, siguro sa sugod is, pwede pa nga ito i-withdraw. Pero kalugayan, makatagtanaw. O giani nga uh, drawing no, for an amplifier. Siguro sa sugod is isa, siguro. So before ta mag-go deep sa atong analysis, to remember the four relationships of parameters, uh, variables for transistors. Pointed out four last meeting. First one, current IE is equal to IC plus I IC plus IE IC IB. Yan na. So pa. VBE is equal to 0.7 volts. So, as mo itong B ug E, this is the base, this is the emitter terminal. So, here to there is na 0.7 volts. So, sa 8, duta og looping, or KVL, 8. So, ba to? C equals beta IB. So IC will be dependent to the value of IB. And also IE equal to beta IB. So these four are the most essential formulas to describe transistor. Okay, all the other all the other formulas of obtain so other parameters like VCE, CE, or even the formula to get IB in the first place is dependent to circuit. Okay. So we have two involved here. This and that could be our loop 2. From loop 1, so wait ha, see? Minus 0. So take note of the sub. From loop 1, it's VCC minus, technically it should be V voltage to RB minus VE equal to 0. So kung dili sa taas, masyagianig. So sa VCC padlong sa ground. Okay? So sa VCC minus IB times RB minus VBE equal to 0. So wala siya si loop 1. Ito ipalat to Adalah VCC minus VRB minus VB equals to 0. And actually, natay value for VBE. VBE is 0.7. BRB. VRB ito, diba? So, BRB is equal to IB times resistor B. So, that's from the second loop, loop 2. It's VCC ACRC minus VBE equal to 0. So, from the emitter equal to 0. So, that's our second loop, or loop 2. VCC minus ito, ICRC minus VCE equal to 0. Okay, so these are our two formulas derived from the fixed bias circuit. Don't need to memorize one. Kung makaya nyo memorize, madali naman siya masubay because giderive man siya from the circuit. Okay? So I guess that's it. No? Marane. So VCC is given, RB and RC are given, IC could be obtained when IB is available. So isa sa mga unknowns, and VCE is the last na unknown. Okay, so far, before I go further, sige, siguro. Example. We try to solve this one. Lagi kami sa book. Okay, I think one is given. So given the fixed bias circuit, let's solve for the currents IB, IC, IE, voltage VCE, and the power dissipated by the transistor. Okay. So why is this important? Because it will let us know if naapa ba siya sa active region or wala pa ba siya sa breakdown region. No? Sige daw. Wait. Na-derive naman na to ang na-derive naman to ang formula. So, pwede ito mag-direct substitution. Okay? Pero, if nakalimutan sa formula or wala na ito memorize, pwede naman na ito gyapon i-subay karon, no? Wait lang sa calculator. First, dito nga loop. No? From 12 volts to ground, gikan na nga loop. No? So, from loop 1, so itong mga encounter. First label sa ta. Again, this is B, this is C, this is E. So, meaning natay junction diri VBE, and napod tay junction here VCE. So, 12 minus, so may current nga flow dire. This is IB, right? IB. So 12 minus IB times 240K minus VBE, which is 0.7. Wait, ako na sa econ siguro. Generalize. VCC minus IBRB minus VBE equal to 0. Okay? So VCC minus IBRB minus VBE, then ground naman, so equal to 0. VCC is given, that's 12 volts. IB is unknown. RB is given, 240 kilo ohms. VBE, 0.7, equal to 0. Therefore, IB could be easily obtained. 12 volts minus 0.7 divided by 240K. It's 47.08 micron. Same tag na ko ang answer. Same ba sa kuan? So 47.08 micro amperes. Then, basta analysis gani nga problem class, dali ra kay na din makuha ang IC ug IE basta nakuha na si IB. Okay? So, analysis man, given na si beta. So, IC is equal to beta IB. IC is equal to beta is given 50 times 47.08 micro. May 50. 2.35 milliamperes. So that's IC. Pag makuha si IC, paapod si IE. IE. Pwede, doon naman ito pamahagyan. Pwede ito beta plus 1 IB. Pwede po mag IC plus IB. Pwede po na. Either way, the same ito makuha ang answer. IC is 2.35 milliamperes. Take note dire kay daghang kasayop so sinugdanan na dili sila parehas og units, no? I mean IC is milli and IB is micro. So take note of that one. This is 2.35 times 10 to the 3 and 47.08 times 10 to the negative 6. So actually, kung di na ako i-solve, approximately, dapat akong answer is nalapod sa nga ng range 2.35 something. No? Okay, micro plus milli equals the bigger milli. No? So actually, the answer yes is 2.40 milli amperes. So far, before I proceed, any questions? Any question, David?
None so far, sir.
So far.
Sir, na may question.
Sige, Gian.
Anang value sa beta, sir, ba given? Gina, sir? Or...
Given na siya. Basta analysis nga problem, more or less given gina siya.
Okay, thank you, sir.
So, sige, if may other question, proceed ko sa pikas nga loop.
Sir, question, sir.
Sige, Arman.
In solving, sir, ba, if we are to, like, find IE, pwede naman i-skip ang part nga, like, pangitawon sa IB since, like, paano naman sa, like, wala ra kay siya, di ra kay ma-affecto ng value ni IE.
Be, need man si IB para makuha si IE. So, kaninga kuan. Dili ba di IE?
Si IC. Yeah. Sorry, sir. Nako, nakita ng kaning left side nga part. Pag-zoom out
okay,
na.
okay.
Sige, sir. Thank you, sir.
Sige. Okay. So, yes, need both si IB and IC. Okay, pagkuha kay IE. So, pikas nga loop here. So, dito nga loop. Gikan kay VCC pag ground gyapon but sa kaninga path. VCC minus IC RC minus VCE equal to 0 na dayon kay ground naman after sa junction CE. Loop 2. VCC minus IC RC minus VCE to 0. So VCC given 12 volts gihapon minus IC is now known 2.35 milli. RC is given 2. Technique sa calculator, multiply ang milli o kilo, pwede na sa dilibutan ng mga times 10 to the negative or positive something. Minus VCE, which is the unknown here. Equal to 0. Therefore, VCE is equal to 6.82. Nasa mga 6.82. If nag-differ ta og answer sa decimal places, it might be make mo og grounding off. Okay na siya, no? Wala problema na. So that's the final answer. Now, how do we determine if our circuit will not go boom? Multiply na to ang current og voltage. ni transistor. So the power of the transistor is equal to IC times VCE. IC is 2.35 milli, VCE is 6.82 volts. Therefore, the power dissipated by the transistor is sa mga 16.06 milliwatts. 16.06 milliwatts. So we could not tell for sure if above ba niya or below, but we could sa specification sheet that we use, dapat kapan below siya. Our transistor is 25. Okay pa na eh. So kani specification sheet kita. Ato kung pila. But we could not check magid for sure kay may gibot ang part numbers transistor sa kanang exam. But yeah, that's it. No? Any questions?
Sir, kaning PT sir mo na yung formula sir always solving for
I
one
solving for
ICBC.
PT.
Okay, sir.
ICBC na siya.
Sir, pwede zoom out gamay ako tanaw ng like bigger picture.
Zoom out. Zoom out. Kani?
Yes, sir, para nang murag full solution bitaw. Given man pod Japon ni permi atong voltage BE sir ba tungod sa kanang 0.7.
0.7, given na siya. Constant na siya. 0.7 na siya per mi atong pag-assume.
Pati ang 50 sa beta, sir.
Dili, kana siya, given na siya.
Okay.
Ang 0.7 lang, constant lang yun siya all throughout. Sa kanila nga circuit, ang atong transistor is characterized by the beta.
Sa kanya ang determine sa beta na sir? Like practically.
Kuan dili kuan na siya. Sa terma. Inherent na siya sa transistor. Malag dito na siya makita sa specs gyud sad. Dili bitaw ang kuan, I mean
So kebali sir
basically
if
given kita siya. Kibali kung
kebali mag-solve sir kay i-give na siya daan kanang beta.
Give na siya daan.
Yes, sir.
So kung kuan siya, no? Kasi for example, practical gid nga circuit actual sa tanan nga value. Malag nahulog nga we are performing this one kay wala tay available na current ammeter o voltmeter. So tay circuit kablo top lagi supply, kablo top lagi value sa resistors kay mabasa naman na sa iyang mga color na stripes and kablo punta sa given nga transistor. Pero wala tay tools, no? Kaya mao magid ang atong ma-cite nga example here nga nung atong ning na perform. Pero most often than not, bali ang kakitabo, no? Given tag transistor, given tag load, given tag load here, pwede dili butang, kung man kanang switch man ni siya. Kung ang amplifier, so kita man mag-decide kung pila to ibutang nga VCC. And depende sa ibutang nato dili nga kuan uh, signal source, and depende pod kung pila ang load sa atong resistance sa atong load. So example ni ha. Kita man magbuot kung pila ang o unsa nga transistor. So sa design, nga problem in contrast sa analysis. Ako na mentioned earlier, this is analysis type of problem. Kay given man tanan, solve for the currents. Here, bali. Sa design, it might be that RC is not given or RB. Tatakbalo pila. We might know pila ang current IB. Kay namantay signal source. Kablo punta pila beta. Kablo man taon sa nga kita mo magpili sa to. So this is an example of a design problem, no? So mawagi ani. Dili man lang tanang design problem ani gyud. Basta if resistor, ang value na gani sa mga components ang unknown, isa na siya sa mga timailahan nga design problem ni siya kay kuan, no? Unknown ang components. And basta inga na gani, sometimes ba dili posible nga lahi tag answers, no? Posible nga lahi answer ni Armand kay Iya, no? Ano sa design problems posible lahi answer. Pero kung analysis type of problem just like this one, for example, isa lagi na siya definite. Pwede, no? Pwede sa design problems lahi mo mga answers. To perform one, same nga kuan, the same quad, no? So makuha sila ninyo yung 2 minutes. Let's say two. I will try to drive a point later, no? Try to solve again for all the currents, IB, IC, and IE. Ignore lang si PT, no? Power dissipated. O VCE, ano lang sila. No? So try to solve again for IB, IC, and IE and voltage VCE. Now that IB beta is 100. Sige, no? Iboto lang usab akong gibuhat. So makauna answer, try to type your the values that you have. Value ni IB, IC, IE, and BCE. Type lang sa chat. Sige, for the next 5 minutes, mapasas mo atong time. Sige daw. All right. I think almost the same anong mga nakuha ng mga values, no? Um, 47 micro. The same as ako sa ganina. Kay ang IB is dili man dependent sa kuan beta. So pala lang IB. Si IC from 2.35 na imong 4.7 and si IE is 4.71. So marg na times 2 mabud no? Almost times 2 pod ang IC ug IE. Okay? Si VC is 1.64. Nigamay? Nigamay, no? So okay, nigamay si VCE. Kung power lugar, 4.708 milli times 1.64, 7.7 milliwatts. Mas kamay ang power dissipation. So this is what happens, no? Or what happened. Over time, it's possible na ang value sa beta is mag-change, no? Pwede siya mag-degrade, pwede gid ma-out completely basta kay nag-change siya, no? Nag-change. So from 50, earlier 50 man to, di ba? From 50, mo siya 100. So ato mga values na is nga change pod. Of course, si IB wala man na sa kay, di man siya dependent sa beta. So si IC from 2.35 na himong 4.708 milli. And si IE is dol gyapon na 4.76 mo tinyo ko ano, 75 no. So 4.76 milliamperes. So mara siya nag almost times 2. No? Times 2 gyud. 2.4, 4.8 no. Almost times 2 si IE, si IC times 2 sa gyud. Na usually dili na to i-connect ang atong load kay VCE. So 6.82. Okay. Or in hindsight na lang, no, ang overall gain is for the most part is magdepend man pud siya kang IE, no, sa IE. So if nila ko si IE, ma-change pod ang atong overall gain, no load gain. So if ma-change the gain, well, dili na siya as intended, no? It's not working anymore as intended or as designed. And dili tungod kay atong gi-change si beta, but patungod kay si beta is nag-change siya value on its own. Maybe it might be nag-degrade siya, no? Sa sige kagamit, no? Sige kainitan, lahi ang value sa beta. So, na times 2. So, na-change wala itong mga values. Currents IC and IE, and voltage VCE. Now, we don't want that to happen. No? We don't want, tungod lang ka nag-change si beta, is nag-change po ang mga kuan, no? mga values. And logically, it will follow magiging ngana, but we don't want that. So, atong conclusion here is the fixed bias configuration is technically not a stable. No? The fixed bias configuration or circuit is not a stable biasing circuit. Because if mag-change ang value ni beta, mag-change po ng all the others, no? Significantly. Now, there are designs that will result in a more stable change sa IC and IE if ever mag-change man ang beta, no? So, ato na siyang topic or matakal so after midterm na. But wala na akong gusto i-point out here, no? That the fixed bias, a simple design as it may be, pero dili siya nga naka-stable. Kung mag-change man ganyang value sa beta, significant po ang changes sa all the other voltages currents. Pero ang more complex designs than this, mag-change man gid na, kung mag-change man beta, mag-change man gid tanan. Pero dili as high as what we can observe here, no? So example, lahi na lang ang scenario po. What if naguba si transistor, no? Naguba si transistor, and we do not know what type of transistor ang originally gigamit. Okay, kung atong tan-awon ang iyang physical nga kuan, ang pyesa, let's say galas pa kaayo, dili na maklaro iyang part number. So we have no way of knowing kung unsa nga type of transistor ang gigamit. Okay? So there are other circuit configurations na even if ibaylo-baylo si kuan, or even if fluctuating or ma-change man ang value sa beta, dili currents of voltages. So that is for higher or more complex biasing circuits. Kung gusto lang taog kuan, simple lang yun nga amplifier, i-go-with maka-step up o volume, I think the fixed bias will do. Pero we cannot expect na shadow output, or we cannot expect na it will last. It will be stable as years go by. Pero yeah, this will do, no? So ang difference sa other more stable circuits is pila man po, duha, tulo, isa ka additional nga resistor naman. So it would be better na lang, no? If original nga pag-design, it would be better to use those more stable and more complex biasing circuits kaysa fixed bias. And sa high, we could observe fixed bias configuration not in amplifier circuits but for switching circuits, no? Mas better pa siguro ang fixed bias for switching circuits and not for amplifier circuits. Okay? Mo to ang outcome example, para ma-observe na to ang kung mag-change magali ang beta sa fixed bias configuration, significant ang changes sa IC and IE. So I might post an assignment related ani para at least makapractice mong solve sa balay. Okay? And is there any more questions? Clarifications? Kaya ba? No? Sa'yo na ba na to those na wala
Aron ang juice assignment, sir.
Sige. Ano sa to, Rainier?
Aron ang juice assignment, sir.
Hello? Napo ba ko?
Hello, sir. Madunggan ra ko.
Madunggan na.
Sir, mag-ask lang ko if karon gyapon na day ang due sa assignment or not.
Ano naman? May concern sa balay?
Wala man, sir.
Sige, di pa manoon tonight. No? Might be tomorrow night siguro. Kuan lang mga 2 to 3, 1 to 2 lang. I mean, 1 to 2 problems lang or questions. At least to practice that's what we've learned or discussed this afternoon. Okay? Yan lang. Sige, thank you
Yes,
for
sir.
your question. Okay. Is there any more? Are there other questions? Kaya na ba? No? Ma-follow na ba ang steps? Actually, copy na ginako ang values na example sa book. Pwede naman tamad. Pero pwede na natutupagtisan ka itong mga nasa sa exercises nga portion. Sige, if there are no more questions, reminder lang siguro, no? Midterm exam will be on, sa ba? Sa Thursday lang siguro. Okay, on Monday, magkuhan siguro ta, no? Mag-solve pa more examples regarding ani. Para at least, kasabot-sabot kita sa, makasabot pa kita sa fixed bias. So, we'll have our midterm on Thursday. Okay? The same nagyapon style sa prelim. Nagyapon multiple choice and nagyapon problem solving. Pero ang coverage is from kuan lang ta. From wave shaping, no? Rectifiers. Sugod lang ta dito. Okay?
Okay, sir. Thank you.
Sige. If there are no more questions, dismiss ta. Bye, guys.
Bye, sir.
Bye, sir.
Thank you, sir.
Thank you, sir.
Thank
you, sir.
Thank you, sir.
Okay.
Bye, sir.
Thank you, sir.
Bye-bye. God bless
Yes,
mo.
sir.
Thank you, sir.
you, sir.
Mm.